3-day trip. Oh yeah, I need to do my presentation.
Might as well
Yeah.
All right. So today, continuing what we talked about yesterday. Yesterday we talked about using the first and second derivative test to figure out where there was extrema. The second derivative test just pretty much tells us that we have either a relative max or min. And then the first derivative test is used to actually determine where those maxes and mins are located, okay? Now the first derivative test also tells us our critical points, which, those are the ones that will tell us whether or not we have a max or a min. But more importantly, also when you look at the first derivative test, it also shows you where your graph is increasing as well as decreasing. Meaning if it's increasing, you have a positive slope. Decreasing means you have a negative slope. All of this is important when it comes down to graphing these functions, which is what we're talking about today, okay? Now, the second derivative test will tell us not only that we have extrema, but more specifically concavity, whether you're being concave up or concave down. And those specific points, when we set the derivative equal to the second derivative equal to 0, those would possibly be our inflection points, okay? Hopefully all those things you guys did write down yesterday. Part of your notes, yes? Good stuff. So, let's just jump right into it. Now, you cannot forget also about, the more simpler things, such as x-intercepts, y-intercepts, things of that nature, okay? How do you find an x-intercept? Set the function equal to 0, plug in 0 for y, and then to find your y. To find your y-intercept, you plug in 0 for x. All right, so let's just jump right into it. Let's look at this function here, okay?
Example?
So x cubed plus x squared minus 5x minus 5, okay? We are going to graph this function. No calculator. Mind you, all this is no calculator, okay? This is a cubic, and so you should have an idea of what a cubic looks like in your mind, correct? Okay, so, and it's positive. So in some shape or form, it should look like this. Okay, so the right end should go up, the left end should go down. It's always good to have an idea of what these things look like. It makes things a lot better when you actually graph them. Okay? So, why not start with the most basic stuff, okay? What is my y-intercept?
5. Or negative 5.
And remember, those intercepts are points, so
0 to negative 5.
0, negative 5. Remember, you get that by plugging 0 in for x. Okay? Now, x-intercepts might be just a little bit harder because here we have a
Cubic.
Okay? So, but we know for sure that's crossing the y-axis at 0, negative 5. What about some extrema? How do I figure out my extrema? Take the derivative and then set it equal to 0, okay? So what is my derivative here?
3x squared plus 2x minus 5.
And we'll set that equal to 0, okay? Can we factor this?
Yes.
Yeah.
3.
Mm-hmm. California method, 3 times negative 5 is negative 15. 5 and negative 3. 3x on top. So 3x plus 5, x minus 1. So x equals, okay? Now those are not my x-intercept, those are my critical points. These could possibly be where my maxes and mins are. So I have to do a number line to figure out exactly if they are extreme, if the extreme does occur there. Okay? So I'm going to pick test points. I can do negative 2, 0, and 2. And I plug these test points into the derivative to figure out if the slope is negative or positive, okay? So let's do that. Let's plug in negative 2, 0, and 2. Alright, so when you apply the negative 2, what you get? And 0,
Negative.
and 2.
Positive.
Okay, so remember, extreme occurs where we change signs here. So if I'm going from positive to negative, that means I have a max, and if I go from negative to positive, I have a min. So that means that from negative infinity to negative 5/3, I am increasing. So that means my curve should be going up. Then between negative 5 and negative 5/3 and 1, I should be going down. And then after 1, I should be going up. Okay, so not only do they tell me extreme, but they basically tell me what's happening with the slopes in between these particular points. Yes?
So would you need to use the second derivative test as well?
Mm-mm. But we will need to find the second derivative just to make sure that we have concavity and we're making sure we're changing from being concave up to concave down. Correct.
Oh, so you would need to use
Yes. So let's find my max and my min point because I'm graphing this. So I need to know where these points are located, okay? So let's do that. Find my point for my max and my min. How do you find that coordinate? Into the original. Plug these numbers into the original. So we got 1 and negative 8 and negative 5/3 and 40 over 27, which is about 1 and some change. Okay? It's like 1 point something. Okay? So there we go. There's our max and there's our min. Okay? Now, we also want to figure out our inflection point, okay? Because our inflection point is going to tell us when it goes from being concave up to concave down. So, to do that, we need our second derivative. Change colors. Which is?
6x plus 2.
And then we set that equal to 0. We solve to get so negative 1/3. We do another number line.
0, or no, negative 1.
We're going to use negative 1 and 0. We plug it back into the, not the original, second derivative. So we plug in, do we get positive or negative? And do we get positive or negative when we plug in 0? So since we're changing signs, negative 1/3 is an inflection point. And this tells us that from negative infinity, bless you, to negative 1/3 is concave down, which goes along with the max occurring. And then from negative 1/3 and up, after is going to be concave up. So let's find that inflection point.
Plug it back into the original.
Plug it back into the original. Did you guys get negative 98 over 27? 88? Negative 88 over 27, which is 3 and some change. So now we have a good amount of information to help us graph. We know what our ends look like, looking here. We know where it crosses the y-axis. We know where a max occurs, where a min occurs. We know where the inflection point is, and we know exactly where I should be increasing, decreasing, and increasing, and concave up and concave down. So let's put it all together in a nice coordinate plane.
Can we only do the inflection point if the change, the sign changes?
Yes.
So if it would have been negative and negative.
Okay. So we know crossing at 0, -5, right? Okay. Where's our max located?
Good afternoon, teachers.
Alright, so I got my y-intercept. Where's my max again? So a little bit after 1 and 40 over 27.
Yeah,
So that's about before 2. I had a min, 1, negative. Oh. And my inflection point was negative 1/3 and a little bit after 3.
What is?
The max was at negative 5/3.
That'd be like not 2 and
Not negative 2 or not negative 1, but in between. So this point is right here, is when you go from being concave down. So, seriously? There it goes. So there's my max. There's it being concave down. I want to change directions. Go concave up, go through my y-intercept, go through my minimum.
Pretty, tight. Do this.
There you go.
So you wouldn't need to find your x.
In situations like this, because they don't stress so much like being able to find your x-intercepts with like higher degree polynomials. But if they start you off with a quadratic, then why not?
And next page. Heartbeat.
Alright, so let's do a different one, okay?
I remember something about this one.
This is what type of a function? The what? Rational. This is a rational. Okay, so you gotta go back and use your knowledge about rational functions, such as rational functions. Well, they have asymptotes. Do they what kind? Vertical. Do they have horizontals?
Yes.
Yes, they do. They got both. You know that they have branches, right? Called hyperbola. They go in like opposite directions. Okay. That's on the gibbers. Okay. But we can.
No inflection point.
So this is a rational function?
Depends what type of rational function we're dealing with. Okay. But we can still find our x-intercept and our y-intercept the same way, plugging in 0 or setting it equal to 0. Okay. So let's do that. Let's find the easier stuff first. Okay. Y-intercept. We plug in 0 for x, and we get a negative 1/2. So we know that exists. Because you have 2 over negative 4.
Oh.
Yeah, so it's x plus 2 over x minus 4. And we can actually find our x-intercepts too for this. It would be negative 2, comma 0. Remember, with rational functions, to find your x-intercepts, just set the numerator equal to 0. Because if you plug in 0 and end up multiplying, the x minus 4 goes away anyway. So we have that piece of information. Okay? Let's find our asymptotes. That's very much key. Let's find our vertical asymptote.
Is that when we set the denominator equal to 0?
Is when you set the denominator equal to 0. So x equals 4. I don't know why I said that. And what about our horizontal?
Is that where it's like the first?
Yeah, I think I never know how to
Is it like power?
Is it
Look at the power.
Power.
find it.
So it's 1, so it's
It's the same.
0.
So 0.
Isn't it 1?
Oh, then you look at
It's,
the
you look at the
coefficient.
coefficients, if they're the same.
Oh, they're the same.
So the coefficients are 1 over 1, which is just 1. So you have y equals 1. Now, if the denominator had been 2, if the bottom had been a degree of 2, then it would have been 0.
Or the top would have been x squared.
If the top had been x squared and the bottom had just been x, then there would be no horizontal asymptote.
The top was
Like the coefficients, then it will be y equals 2 over 1, which is just 2. Okay? So we got a lot of good information here. Let's figure out if we got any maxes or mins, any extrema.
When do you know when there's none?
None what?
No horizontal.
If the numerator is bigger than the denominator. That's when you know there'll be no horizontal asymptotes. Okay? Let's go ahead, let's find our derivative so we can figure out some extrema.
Oh, it's quotient rule.
It is quotient rule. So go ahead and
Kind of nasty.
Do it.
Begins and over what?
It's zero.
Then you multiply the. Open the bottom cross.
I don't think it's really good, so oh, so when we were having our ACT review, make sure we're doing this around the world.
How short are the children?
They could be as. So here, we find the derivative and we simplify. We get -6 over x minus 4 squared equals 0. And then when we try to solve that, what happens? There's nothing. So there are no critical points, okay? There are no critical points, which means that if there are no critical points, there are no extrema. There's no max and there's no min, okay? Now, just because there are no maxes and mins doesn't mean that you can't have inflection points, okay? Doesn't mean that it can't be concave down or concave up or anything like that, okay? So, let's find our second derivative, okay?
I feel like if
Be a
I had
quotient.
critical points in
Again,
I'm sure.
okay, so there's the first derivative.
Oh, that makes no sense. How do you have zero on the top? I've never understood that. What is
Zero.
multiplied by zero?
Also, all of these also.
No, it would be, when you said equal to zero.
2,
This,
4, 6, 7,
That wasn't with the negative one.
so that you just said negative 4x on 40.
The negative make a positive.
For the whole thing.
subtract 0 minus 3.
Oh, I didn't write
Where'd you get negative?
that. Okay,
Because -6 is a part of the first derivative. So low d high minus high d low all over low squared, and you get this. And to find if we have any inflection points
oh, it's an equal.
set equal to 0, you will actually have something this time.
It's 2 of them.
You would have
Just cross out.
x equals positive 4, right?
I got the. I got trade 12x.
Wait, what did you do with the bottom?
Okay, so negative 12x minus 48 equals 0.
Okay.
Add 48, divide by 12.
So what did you do with the bottom?
So,
Wait,
When you multiply both sides
Oh,
by
you
0,
said equals
or,
I got a different second derivative. I got negative 12x plus 48.
Okay.
so I did that wrong.
Yeah, so if I flipped it, but it still gets me the same thing. Does that matter?
so you had x plus 4 here?
I got,
That's the only way I can see you actually.
I had negative 12x was
I
40
had
and
negative
said
12
4.
times.
Wait, wouldn't it be minus
Divided
40?
by
No.
negative.
Yeah, that's what I did.
Negative
Okay.
48.
So I just flipped it off.
Oh,
Loaded
We
it.
want to make sure that's an inflection point, okay? So if I'm plugging 4, the numbers 0 and 5, or 1 and 5, 3 and 5. So I'm plugging 0 into the second derivative, which is located right here. I end up getting,
Yes,
I get a negative,
Isn't that what fine?
and then a positive. 4 would be. So that means that I'm concave down from 0 to,
How do we have a con?
okay. So this is what we have here when we test these points. Now, one thing that we gotta be careful of, I forgot this, so of course I didn't mention anything about it, but I remember it now. Even though we didn't have any critical points, we still have some critical pieces of information, i.e. those asymptotes, okay? We had a vertical asymptote at 4, we had a horizontal asymptote at 1, okay? So even though we might not have any maxes or mins, because based off of a critical point, we still need to check around those asymptotes as well.
Those are kind of restrictions, right?
Mhm.
So we get
So we gotta take those into account as well. So remember, anytime that you have any type of asymptotes, and say you have some other critical points as well, you have to also include those as restrictions because you're neither increasing nor decreasing at those values because they're undefined there, okay? So those are some critical points. So let's just back up real quick. We have this information, but let's back up here. We have a vertical asymptote at x equals 4. So let's test around 4 to make sure that, you know, that we're still good to go. And then we also are gonna have, well, we tested 4 over there because I think this is next over. So what's the number to the left of 4 and to the right of 4 that we can test inside of our first derivative? 0 and 5. So when I plug in 0, do I get a positive or a negative?
Oh, the derivative.
And so the first derivative,
Oh, negative.
Negative.
you get a negative and
Negative.
you know what?
7 over 1.
Is that negative?
negative,
If I plug in 5, I get a,
negative 6 over.
so it is still negative. Now, yes, we still do not have any maxes or mins, but at least now we know that from negative infinity to 4, we are decreasing, and we're also decreasing from 4 to infinity. Okay? We are concave down from negative infinity to 4, and we're concave up from 4 to infinity.
How does that work? It's a little arch.
It's a little hyperbole. So that right there, we're decreasing, and that's concave down. Going down.
Oh, I get it. So it's 2 different ones.
Mm-hmm. So we have all our information. Let's graph this. We have a y and an x-intercept.
What was our?
What was our?
Inflection point?
We didn't have.
I thought it was.
Well, it was also an asymptote though. So it's because because it is going to change because of that asymptote there. So at 4 we have an asymptote.
Do we test one?
Oh, it's based off our x's. Was it a positive one or negative one? Okay. We had a y-intercept at 0, 1/2.
Negative
Okay. Negative 1/2. And we had an x-intercept at,
1.
we are decreasing and concave down from negative infinity to 4. This is a bad curve. Make sure it's a smooth curve. And after 4, it is decreasing. If you remember anything about rational functions, opposite of each other. So one's in the bottom left, the other one's in the top right. And that one needs to be decreasing.
So when you have someone where it actually cross the x-axis,
Mhm. Right here.
why didn't we have any critical points?
Critical points just tells us if we have maxes or mins, not x-intercepts. Now you might be thinking
Can there ever be,
that
Oh, he's talking about myself.
Oh yeah, like cubic or something, where
do we ever have diagonal asymptotes?
they do exist, but not you won't even know them.
Would then you have in that?
Then you would have a then you have diagonal asymptote, and then you have
that'd be pretty rare.
What's that?
Having an asymptote that is
Okay. So there you go. Now you guys, when you are graphing these, okay, again, you can use all your tests to figure out all this important information. But also realize that you need to be able to go from the graph of the original to the graphs of the derivatives with no equation, just the graph itself, okay? So you do need to be aware of a couple of things. That when you're given a graph of a function, not the equation itself, but just the graph of the function, okay? Whenever there's a max or a min, there is an x-intercept. Okay? So, Whenever there's a max or a min, there's an x-intercept.
For the function.
Doesn't matter either way. Alright? Remember, if your slope is negative, then that means you are decreasing, and if your slope is positive, that means you're increasing. And also, do not forget about your most basic things about derivatives is that when you take a derivative, you are decreasing a power. So if you start with the cubic, you go to a quadratic, and if you take the derivative of that, you go to a linear function. All those things are helpful when it comes to actually graphing derivatives of functions straight from the graph, not the actual function itself. Okay? So we're going to look at one real quick.
I love these.
Okay? We're going to look at one real quick before you guys go. We'll do the most basic one.
Oh, yeah.
Extremes. There's a max
I love
and an intercept. Oh, that's what you meant.
Okay? So here's your original function. Here's f of x. Okay? We are going to graph the derivative. There's no equation. There's just the graph itself. Okay? So whenever there's a max or a min, there is a x-intercept. So since there's a max here, there's an x-intercept. And since there's a min here, there's an x-intercept. Okay? Remember, the first derivative is slope. So look at the slope at different points. From negative infinity all the way up to negative 2, I am,
Increasing,
and since I'm increasing, that means that on my derivative, I'm going to be
decreasing.
above the x-axis. I'm going to be positive. I'm going to be in the positive section. Okay?
I never.
Since my slope is negative from negative 2 to 0, I'm going to be
Under the X.
under the x-axis.
And then backwards.
And then from 0 into infinity, I'm going to be
Above.
above.
And when there is a point of inflection.
And whenever there's a point of inflection, such as here, there's going to be a min or max. Which one is it? I'm going from a positive to negative, or I'm going above the x-axis to below,
Min.
so it's going to be a min. Now, where exactly it's located really doesn't matter. Okay? So, we're above the x-axis because we're increasing, we're below the x-axis because we're decreasing, and we're above the x-axis because we're increasing again. And that orange is the derivative.